Hi, welcome back. Today we are going to go over flow control, which is the next chapter, and automate the boring stuff with Python. So as usual, we'll go through the diagrams here and do some examples. So first, we're going to go over the basics of flow control. So let's just start with this diagram here. So as you can see here, there's a start point and an end point, and this program will run as long as the conditions are met. So in this case, is it raining? No, then go outside. Or if yes, then if you have an umbrella, then go outside. If no, wait a while for it to stop raining. And if it's still raining, you wait a while more. And if it's not raining, then you go outside, and then it ends the program. So usually there's more than one way to go from the start to the end point here. As you can see, there's multiple paths that you can take. So one way we implement that in Python is with Boolean values. So there are two types of values here, and that is true and false. So let's just kind of go over some examples here. So we have spam equals true, and then we print spam, which will give us true. Basically, we assigned the value true to spam. And then if we type in true, obviously it's not defined, it's treating that as a value. Same thing when we do true, capital T equals 2 plus 2. So like any other value, Boolean values are used in expressions and can be stored in variables. If you don't use the proper case, or if you find or you try to use true and false for variable names, Python will give you an error message. So next we have comparison operators, which are also called relational operators, and they compare two values and evaluate down to a single Boolean value. So kind of like last time, we have equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. And these operators evaluate to true or false depending on the values you give them. So let's go ahead and try those out here. So 42 is equal to 42, which we know is true. 42 is equal to 99, and we know that's not true, which is false. So 2 does not equal 3, true. 2 does not equal 2 will be false. So this also works with values of any data type. So for example, we have strings here. So hello is equal to hello, which is true. However, if we do hello is equal to capital H hello, we will get a false value. So basically we're looking for matching strings here, and obviously when you have a capital H, that slightly changes it. So even though the word is the same, the string value is different there. So let's just try a few more here. Does not equal cat, which is true. True equal to true. This will give us an error because I misspelled that. So clear that. Then we have true does not equal false, which is true. 42 equal to 42.0, which is true because mathematically those are the same numbers. However, the integer value and the string value 42 are not the same. Next, we're going to go do the greater than or less than operators. So 42 less than 100, which we know is true. 42 greater than 100 is false because mathematically that is incorrect. Same with this one. Those are both the same values. They should not be greater than or equal to each other. We're making a new variable here, assigning 42 to it, the integer value, and then we call a count is less than or equal to 42. There we go. We know that's true because while 42 is not less than 42, it is equal to 42. And lastly, my age equals 29. Age greater or equal to 10, and that is true. So there's a difference between the equal to and equal operators. The equal to asks whether two values are the same, and the equal operator, this is an assignment operator, puts the value of whatever you're trying to assign to a variable that you have created. There are three Boolean operators: and, or, and not, and these are used to compare Boolean values. For the binary Boolean operators, we have the and or operators, which always take two Boolean values or expressions, so they're considered binary operators. So let's demonstrate that a little bit. True and true, which is true, true, and false, false. We have a truth table here that shows every possible result of the Boolean operator. So I won't punch those into the command prompt here, but you can kind of read that. So true and true is true, true and false, false, false and true, false, false and false, false. On the other hand, the or operator evaluates an expression to true if either of the two Boolean values is true. If both are false, it evaluates to false. So we can try that out a little bit. So we have false or true, and it'll go to true, false, or false will evaluate to false. And then we can see every possible outcome of the or operator in its truth table shown in this table here. True or true is true, true or false is true, false or true is true. Notice how these are going to be the same evaluation, and then false or false is false. The not operator, unlike and or, the not operator operates on only one Boolean value or expression. This makes it a unary operator. The not operator simply evaluates to the opposite Boolean value. So if we do not true, we get false. And if we want to have fun here, true. Much like using double negatives in speech and writing, you can nest not operators, though there's never no reason to do this in real programs. Table 2.4 shows the truth table for not. So we have not true, false, not false, true. Since the comparison operators evaluate two Boolean values, you can use them in expressions with the Boolean operators. So here we're mixing Boolean and comparison operators. Recall that the and, or, and not operators are called Boolean operators because they always evaluate on the Boolean values true and false. While expressions like 4 is less than 5 aren't Boolean values, they are expressions that evaluate down to Boolean values. Try entering some Boolean expressions that use comparison operators into the interactive shell. So let's go ahead and do that. So we have 4 is less than 5, and 5 is less than 6. We know that to be true. 4 is less than 5, and 9 is less than 6. We know that's gonna not be true because 9 is greater than 6. We have 1 equal to 2, or, and this is important, 2 equal to 2. Now the reason that's true, obviously 1 does not equal 2. However, when we use the or operator, it's picking one or the other if there is a true value here. So this diagram is talking about how the expressions are evaluated down to a single expression. The Boolean operators have an order of operations just like math operators do. After any math and comparison operators evaluate, Python evaluates the not operators first, then the and operators, then the or operators. So here we have elements of flow control. Flow control statements often start with a part called condition and are always followed by a block of code called the clause. Before you learn about Python-specific flow statements, I'll cover what a condition and block are. So conditions, the Boolean expressions you've seen so far could all be considered conditions, which are the same thing as expressions. Condition is just a more specific name in the context of the flow control statements. Conditions always evaluate down to a Boolean value, true or false. A flow control statement decides what to do based on whether its condition is true or false, and almost every flow control statement uses a condition. Blocks of code. Lines of Python code can be grouped together in blocks. You can tell when a block begins and ends with the indentation of the lines of code. There are 3 rules for blocks. Blocks begin when the indentation increases. Blocks can contain other blocks. Blocks end when indentation decreases to 0 or to a containing block's indentation. Blocks are easier to understand when looking at some indented code, so let's find the blocks in a part of a small program shown here. So we're going to go ahead and type that up. So we're just going to add a new file here. And we're just going to name this chapter 2. Okay. We're assigning the name variable here. And then the password variable. This is going to be our first block here. And then we're going to go back on the indentation there for this else operator here. Print. Didn't quite do that right. Wrong password. Go to that, and that should be it. So we're going to go ahead and save that. And then we're going to go ahead and run that and kind of walk through how that works. So we have our first error here, which means we forgot something, and I already know what it is, but we're going to kind of walk through this to troubleshoot a little bit. So we're going to read the error code. So it's talking about how on line 7 there's a problem with else. It's a syntax error, and it expected a colon right there. So we're going to go ahead and confirm that. Add the colon here without fat fingering anything else. I'm going to save that again and run it. Okay. So right here, we assign the variable name to this string Mary value. We assigned a string value to the variable password, and we asked if the name is equal to what we had up here. Then we print the message here, and if the password is equal to the password we assigned up here, we're going to print this statement here, else wrong password. So for example, if I edited this to just that, and then we run it again, we're going to get wrong password. So this next section here is talking about program execution. Not every program goes exactly line for line. If you have statements, operations, and loops, obviously, the program will go through on various different paths depending on conditions. So next we're moving on to flow control statements. And this first one is the if statement. So in plain English, if an if statement can be read as if this condition is true, execute the code and the clause. So in Python, we're going to do, so let's clear this first. If name equals Alice, print and of course that's not going to work, so first we need to do name equals Alice. So we just assign that variable, and then we're going to go back up and do that one, and we have the result. All flow control statements end with a colon, as we discussed earlier with this error here, and are followed by a new block of code, the clause. This if statement's clause is the block with print hi Alice, figure 2.2, shows a flow chart of what this code would look like. So we have a start here, we have a true condition, which is the name does in fact equal Alice, and then we go back to the end here. And if the name does not equal Alice, it will also end. So the next talks about else statements. So this is kind of adding on to the if statement, basically. So if you have if this condition is true, continue, or use what's underneath the if statement. Else is basically if this condition is not met, you do something else here. So once again, we're just going to make sure that that is assigned. And we do if name equals Alice, print Alice, and then we can do else print hello stranger. Okay. And then we can go here to change this to Alex. And then we'll go back through and we see the result if the name is not Alice. So once again, another diagram explaining this. You have the condition is true, you go to the end and you print hi Alice. If the condition is false, you print hello stranger, and the program ends as well. Next we have else statements. While only one of the if or else statements, while only one of the if or else clauses will execute, you may have a case where you want one of many possible clauses to execute. The else statement is an else if statement that always follows an if or another else statement. It provides another condition that is checked only if all of the previous conditions were false. In code, an else statement always consists of the following: the elif keyword, a condition that is an expression that evaluates to true or false, a colon, starting on the next line, an indented block of code called the elif clause. So we're going to add that to our name checker program here. So instead of else, we're going to do elif. Forgot to add a colon. Print you or not Alice kiddo. I forgot to actually add age less than 12. And obviously that won't work because we have not defined age. So let's just go ahead and add age equal to 12. And we run that previous program. There we go. And then if we change to 13, the same conditions are there, so let's change that to age equals 10 and get the same one. So let's do age. Let's change the name to Alex. Run that again. There we go. Now we get the output that says we are not Alex. Let's go ahead and clear that. So that starts the condition. If the name is Alice is true, it goes all the way to the end. If that condition is false, it checks for the age. If the age is also false, it would go to the end. If it's true, it'll print you are not Alice. So here we have another example here, and we're actually going to go ahead and try that out. So I already have that filled out. So we assigned a name here, an age, and this is our first if statement here. If the name is equal to Alice, we print hi Alice. If age is less than 12, you are not Alice kiddo. If age is greater than 100, you are not Alice granny. Else print unlike you, Alice is not an undead immortal vampire. So let's go ahead and actually run that and just see what comes out. So basically it's saying we are not Alice because our age is greater than 100 and our name is not Alice here. So it'll go through checks. Name is not equal Alice. It'll go if age is greater than 10. Sorry, greater than 100. It goes to this statement. And then skips this last one here. And you see this in the diagram here. Now we can change that. So we have Carol 3000 name equal to Alice. If age is equal to 12, print age greater than 100. If age. And this is where things change a little bit. Greater than 2000. Save and run. So it's saying here that you might expect the code to print the string unlike you, Alice is not an undead immortal vampire. However, because the age greater than 100 condition is true, after all 3000 is greater than 100, the string you are not Alice granny is printed and the rest of the elif statements are automatically skipped. Remember that at most only one of the clauses will be executed, and for elif statements that order matters. So obviously if you swap these around, things will change. Notice how the diamonds for age less than 100, greater than 100, and age greater than 2000 are swapped. Optionally, you can have an else statement after the last elif statement. In that case, it is guaranteed that at least one and only one of the clauses will be executed. If the conditions in every if and elif statement are false, then the else clause is executed. For example, let's recreate the Alice program to use if, elif, and else clauses. So we're going to go ahead and age equals 12, add this else statement here, print and run that. There we go. You are neither Alice nor a little kid. And that's because this condition here is not met. This one is not met as well, and it'll go straight to the else statement here. So this is talking about it right here in these two diagrams. Next, we're going to move on to while loop statements. You can make a block of code execute over and over again using the while statement. The code in a while clause will be executed as long as the while statement's condition is true. In code, a while statement always consists of the following: the while keyword, a condition that is an expression that evaluates to true or false, a colon, starting on the next line, indented block of code called the while clause. you can see that a while statement looks similar to an if statement. The difference is in how they behave. At the end of the if clause, the program execution continues after the if statement, but at the end of the while clause, the program execution jumps back to the start of the while statement. The while clause is often called the while loop or just the loop. Let's take a look at the if statement and a while loop that uses the same condition and take the actions based on that condition. Here's the code with an if statement. So spam equals 0 if spam is less than 5. Oops, we have to assign a colon there. Print hello world. Spam is equal to spam plus 1. Okay. And then we're going to do the same thing with a while statement. This one will actually run a loop for us. And then we see hello world printed 4 times because we're starting with 0 and until we get to 5 loop iterations till that statement is met. And the reason this ran 4 times is because when I ran the if statement, it added +1 to spam. So if we actually, we're going to reassign spam equal to 0, and then we're going to run that while loop again, and that should actually give us 5 instead of 4. So we have this piece of code pulled up right here. So we're going to go ahead and run it within the terminal here. So I'm just going to do what it says here just for right now. And as you can see, it's not quite working, but if I put your name, there we go, it completes the loop. So obviously what I was looking for was this text right here, that string, your name. Next, we're talking about importing modules, which is a prominent Python feature. So first I'm going to clear that. So all Python programs can call a basic set of functions called built-in functions, including the print, input, and length functions that you've seen before. Python also comes with a set of modules called the standard library. Each module is a Python program that contains a related group of functions that can be embedded into your programs. For example, the math module has mathematics-related functions, the random module has random number-related functions, and so on. And the way to call those is to use the import keyword and the name of the module. So let's go ahead and try that. We're going to go to print random. Right here, you can see I have import random, which is our function here for I in range of 5, print random.rand int, the int for integer, between the ranges of 1 and 10. So it's important not to also, actually let's go ahead and run that real quick just to show, 4, 5, yep. So it's printing for an I in range of 5, it's printing random numbers between the ranges of 1 and 10. When you save your Python scripts, take care to not give them a name that is used by one of the Python's modules, such as random.py, sys.py, os.py, or math.py. If you accidentally name one of your programs, say random.py, and use an import random statement in another program, your program would import your random.py into the Python's random module. So you'll have attribute errors and all sorts of fun stuff that you'll have to troubleshoot and figure out. You can also import multiple modules as well at the same time from import statements. An alternate form of the import statement is composed of the from keyword followed by the module name, the import keyword, and a star. For example, from random import star. With this form of import statement, calls to the function in random will not need the random prefix. However, using the full name makes for more readable code, so it's better to use the import random form of the statement. And then ending a program early with the sys.exit function. The last control concept to cover is how to terminate a program. So programs always terminate if the program execution reaches the bottom of the instructions. However, you can cause the program to terminate or exit before the last instruction by calling the sys.exit function. Since this function is in the sys module, you'll have to import sys before your program can use it. So then we're going to go ahead and open exit example.py, and I've already went ahead and typed that up. We're just going to do exit. And then it exits here. So as you can see here in my code, we have sys.exit. If the response equals exit, and it automatically goes straight to the end of the program. So the examples I've shown you so far are useful for introducing basic concepts, but now let's see how everything you've learned comes together in a more complex program. In this section, I'll show you a simple guess the number game. When you run this program, the output will look something like this. And so here it's giving you guesses, you make a guess, and then if you win, you pass. If not, then it'll say you did not win. So let's go ahead and pull that up here. So I already wrote this course, and let's play the game a little bit. So I'm going to start with 10, too low, so I need to do 15 maybe. Oh, that was a typo. Too high, let's try 12, too low, 13, too low, 14. There we go. So one important thing to note is I'm importing the random module, and you can see me using it actually right here. So secret number, and this is the one that's generated by the program, is random.rand integer, and then that's any number between 1 and 20. So that once we have the program generate that number, now it's our turn. So we have to make guesses, and they give us only 6 guesses here because we have between 1 and 7. And then based off of whether or not that guess is greater than or less than the secret number, it'll tell you your guess is either too low or too high. However, there's an else as well, and it breaks. If the guess equals the secret number, then it'll print good job, you guessed my number, and then it'll give you the amount of guesses taken. If not, it'll say the number I was thinking of was, and then it'll give you the secret number. So next we have a short program, rock, paper, scissors. So let's use the programming concepts we've learned so far to create a simple rock, paper, and scissors game. So this is a little bit more complicated and a much longer program to write. So I went ahead and wrote that all ahead of time, but I'll just kind of walk through this code. So once again, we're importing the random module. We're going to print rock, paper, scissors as the start of the game. We're predefining wins, losses, ties. And then while true, so this is the main loop that basically runs the entire game here. We're going to print our wins, losses, and ties every round. So once again, we have the player input loop right here, and then we're going to print enter your moves. This is just a command, or rather a statement that it's giving to the user. If we assign the player move here, we also have a exit function here. So if we type in the letter Q at any point, it'll actually run the sysexit and terminate the program. So right here, we're defining if any of these player moves are used, it'll break, and it'll also tell us to use any of these functions. So rock, paper, scissors, or quit. So outside of that, we're going to do the, we're going back into the main loop here, starting with if the player move is equal to R, it'll print rock versus, and so on and so forth for paper and scissors. And then here's what we're displaying. This is where we're displaying what the computer chose. So the computer's just going to choose a random number between 1 and 3. And each of these numbers is assigned to either rock, paper, or scissors. And then this is where it actually compares whether or not who won based off of what you chose and the computer chooses. And then this whole loop will actually add to this total number here. So let's go ahead and run that and just play around with it a little bit just to see what would happen. So I'm going to go ahead and pick paper. So say paper versus rock. So I won that, but I'm not sure why I didn't add that as a win. In fact, let me actually troubleshoot that a little bit. Just play around a little bit more. Scissors, there we go. So now the next time I went through, it actually updated the wins here. So scissors versus paper, you win. And then I'm going to do rock just to show. And I lost that round, but it shows my wins, my losses, and ties. And then I'll click Q, and that'll terminate the program there. So to sum this all up, by using expressions that evaluate to true or false, also called conditions, you can write programs that make decisions on what code to execute and what code to skip. You can also execute code over and over again in a loop while certain conditions evaluates to true. The break and continue statements are useful if you need to exit a loop or jump back into the loop start. These flow control statements will let you write more intelligent programs. You can use another type of flow control by writing your own functions, which is the topic of the next chapter. Okay, so let's go over some practice questions real quick here. So what are two types of the Boolean data type? How do you write them? So we know that they are basically true and false. And then what are three Boolean operators from above? It's and, not, and or. And then they ask us to write out the truth tables of each Boolean operator. That is every possible combination of the Boolean values for the operator and what they evaluate to. So I'm not going to do that, but I'm going to scroll up back to our tables here where it talks about that. There we go. So we have, and I'm just going to review this real quick. True and true equal to true, true and false, false, false and true, false, false and false, false. And then we have true or true, true, true or false, true, false or true, true, false or true, false. So notice the difference between these two tables. We have and then we have or. And then we have not true, false, not false, true. What do the following expressions evaluate to? So we can actually try that out. So 5 greater than 4 and 3 equal to 5. And that'll be false because 3 does not equal to 5, and that's an and evaluator. We have not 5 greater than 4. That is also false because 5 is greater than 4, not greater than 4. Got 5 greater than 4, or 3 equals 5. And this one will evaluate to true because even though 3 does not equal 5, because of this or, it's picking the one that is true. But then if we do the same thing, and instead we do not parentheses, we'll get false instead. And then we have true and true and true equal to false, which will give us false because the statement is not correct and it's an and. However, if we do not false or not true, we'll get true. What are the 6 comparison operators? So right here we have all of our comparison operators: equal to, not equal to, less than, or equal to, greater than, or equal to. And when we use these to compare values, and Boolean values is involved with that as well. What is the difference between the equal to operator and the assignment operator? So we know that the equal to is basically comparing two values, and the assignment operator equals. So this is the equal to, and then this is the equals operator. So we can do number equals 0, number equal to 1, we'll get false because basically it's comparing the number which we assign 0 to 1, which are not the same, and it'll give us false here. Explain what a condition is and where you would use one. So a condition is something, in our case, we would use it in a loop, and as long as that condition is true or false, depending on how you set up the loop will continue or end. Identify the 3 blocks in this code. So we have our first value here, we have this first block, which is our if spam equals 10, and then it has two more blocks in here, so if and then else, and then we'll have our print statements here. Write code that prints hello if 1 is stored in spam, prints howdy if 2 is stored in spam, and prints greetings if anything else is stored in spam. So let's go ahead and do that. So we're going to do new file. We're going to name it hello spam.py. Spam equals input. Okay. So we're basically allowing the user to decide what they want to put into that. So if spam equals 1, print, and there are multiple ways to do this, but I'm just going to do it this way, print hello. If spam equals 2, print that's howdy, and then now sometimes you can do an else statement. However, that opens up any other option outside of 1, 2, and 3. Well, actually, okay, so we have 1 and 2 for hello and howdy. Now we add the else statement. And then we can just do colon print whoops, looks like I accidentally ran the program. That's fine. Print greetings. Okay, let's save that and run it. Okay, it was stuck in the Python terminal there. So we're going to enter 1, greetings. And then if we run it again, we're assigning the value 2 to spam. And then we'll get greetings. And then if we run it again, try 3 greetings. Okay, so obviously what's going on right now is we're getting different results based off of the input. So let's just try something else real quick. So let's just assign spam equal to 1 for now. And let's try running that. Okay, hello, okay, that makes sense. Try 2. Howdy, so that's not right. I think I know what's going on here, so I'm going to indent that. Indent that as well. So why is it not happy? So it's not happy with the indentation. Fair enough. Okay, so it's happy with that. Okay, so I fixed the program here. So there appears to have been some indentation errors. I also fixed the issue with the input not working properly. So now I assign spam is equal to integer input right here, so that way it'll actually read any of these inputs as integers and not anything else. So we have a spam is equal to 1, print hello, spam is equal to 2, print howdy, else print greetings. So let's just run that real quick. Let's try 1, it'll say hello, just like we asked. 2, howdy. 3, greetings. So that does exactly what we needed to do. So number 10, what keys can you press if a program is stuck in an infinite loop? We talked about that earlier. We would press the Control-C button. What is the difference between break and continue? So break will break out of whatever loop it's in, and continue will go to the next iteration of that loop. What is the difference between range 10, range 0, 10, and range 10, 0, 10, 1 in a for loop? So first of all, we have just the value 10 here for range, and it'll increment for all the values in this range here. We have range 0 to 10, so it starts off with 0, it goes to 10, and then we have 0, 10, 1. It'll increment by 1 for each of these values between 0 and 10. So write a short program that prints the numbers 1 to 10 using a for loop, then write an equivalent program that prints the numbers 1 to 10 using a while loop. So let's go ahead and try that out. So for I in range 1 dash 10 print I, and then we're going to add I equals I, 1. We can see here 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we can actually bump that up to 11 if we want to actually include the value 10 in there, as you can see there. So next we're going to try that with a while loop. While. So we need to assign I equal to 0 while I actually is less than 11. Print I, and then I is equal to I plus 1. And then we can see here it prints all the numbers 0 all the way, and we can actually do I is equal to 1. And we can see all the numbers 1 through 10 right there. So we can kind of see the difference here. So with a for loop, we're defining I in a range here. We're printing I, and for both of these, we're actually adding I is equal to I plus 1. For the while loop, so the condition is while I is less than that number, it'll keep going through that loop continually. This will just go through that range. If you had a function named bacon inside a module named spam, how would you call it after importing spam? We would use a from import statement. So we can have from random import and then the name. For some extra credit, look up the round and ABS functions and find out what they do, and then we can experiment on the shell here. So the round function returns a floating point number that is rounded to the specific number with specified number of decimals. So we have round number of digits. We can see x is equal to round. So let's go ahead and try that. Equals round 5.76543, and then we do print x, and it'll round up to 6 here. And we actually went over this on the last video. And then let's try the ABS function. Returns the absolute value of a number. So let's try that, equals ABS negative 7.25 x, and that is 7.25 since the absolute value of negative 7.25 is equal to the positive value 7.25. So that's it for this chapter, and I will see you for the next video.